everyone, we're going to find the Taylor series for f of x equal ln of x centered at a equals 2. We're going to write it in the definition of Taylor series, and we first need to crank out some derivatives. So we're going to start with 0. So if we have f of 2 for ln of x, so we're evaluating at x equals 2, then that's going to equal ln of 2. For n equals 1, that's where we're going to do f prime at 2, which is 1 divided by x, and evaluating that at x equals 2 gives us 1/2. Now at 2 we have f, the second derivative evaluated at 2. The second derivative of 1 over x is negative 1 divided by x squared. And you evaluate that at x equals 2. That's going to give you negative 1 divided by 2 squared. All right, let's try the third one. F triple prime of 2 is going to equal 2 divided by x cubed. Evaluate that at x equals 2, and that gives you 2 divided by 2 cubed. All right, and n equals 4, we have the fourth derivative at 2. That's going to be negative 6 divided by x to the fourth power. At x equals 2, that gives us negative 6 divided by 2 to the fourth power. Let's try one more. Excuse me. At 5, we have, this is n equals 5, f, the fifth derivative at 2. That's going to be 24 divided by x to the fifth. And evaluating that at x equals 2, that gives us 24 divided by 2 to the fifth. All right, so basically writing it as a sum, right here we're going to get f of x equals ln of x, which equals the sum from n equals 0 to infinity. And we're taking all our derivatives, so f of n of 2, centered at 2, divided by n factorial times x minus 2 to the power of n. So let's expand this and see what we have. When you expand this, we're going to get this equals ln of 2 divided by 0 factorial times x minus 2 to the power of 0 plus 1 divided by 1 factorial, 2 factorial, x minus 2 to the first power, then plus negative 1 divided by 2 factorial times 2 squared times x minus 2 squared plus 2 divided by 3 factorial times 2 cubed. That's going to be x minus 2 cubed plus a negative 6 divided by 4 factorial times 2 to the power of 4, x minus 2 to the fourth, plus, we can go on and on, 24 divided by 5 factorial times 2 to the power of 5 times x minus 2 to the fifth power plus dot dot dot. And this simplifies to ln of 2 plus the sum from n equals 1, because we're writing ln of 2 first. This just equals 1. So we have to up this. So starting with this term here, that's n equals 1. To infinity of negative 1 to the power of n plus 1 times n minus 1 factorial divided by n factorial to, times 2 to the power of n times x minus 2 to the power of n. All right. And simplifying this further, we're going to get ln of 2 plus the sum n equals 1 to infinity of negative 1 to the power of n plus 1. And this is be 1 divided by n times 2 to the power of n times x minus 2 to the power of n. All right. So basically, the reason that happens is before we had n minus 1 factorial divided by n factorial. So this here can be written as n factorial times n, or n, sorry. This can be written as n times n minus 1 factorial. So these would cancel out. All right. So that's why you just have an n left. Now, let's go ahead and look at our radius of convergence. So to do that, we're going to take the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. So we're going to take what we had before, and we're going to get the limit as n approaches infinity. And for this numerator part, we're going to get negative 1 to the power of n plus 2 times x minus 2 to the power of n plus 1 divided by n plus 1 times 2 to the power of n plus 1. Now for this piece, all we have to do is multiply by the reciprocal, which is going to be what we had, n times 2 to the power of n divided by negative 1 to the power of n plus 1 times x minus 2 to the power of n. Let's reduce all this out, and this is going to give me the limit as n approaches infinity. And looking at my negative 1, that's just going to give me negative 1 because the n's will cancel. So we just have negative 1 to the first power. Looking at this piece, you're going to have n minus n, so that's just going to be x minus 2 to times n, and the denominator, so times n there. This is to the first power. And then for this piece, we're going to get n plus 1. And for these two, that's just going to be times 2. All right. This also simplifies to the limit as n approaches infinity of n divided by n plus 1 times the absolute value of x minus 2 divided by 2. All right. So the limit of this piece here is just 1. All right. And so we're looking at this piece here for our convergence. We're going to take absolute value of x minus 2 divided by 2 and set it less than 1. So we have absolute value of x minus 2 is less than 2 when you cross multiply. So for convergence, this has to happen. And our radius of convergence is 2. And that's it. Thank you. Have a nice day. Bye-bye.